Today's lesson is called Proportional Relationships. It's based on the standard with the star that you can see here. Determine whether two quantities are proportionally related. That's what we'll be learning to do in this lesson. Example 1, pay by the ounce frozen yogurt. A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed his dish, and this is what they found. Determine if the cost is proportional to the weight. So we have weights on top. We have 12.5 ounces. That cost $5. Another member of the family weighed theirs. It weighed 10 ounces, and they paid $4. So I want you to think for a moment, does everyone pay the same cost per ounce, and how do you know? So this would be a good time to pause the video and think about this question. Does everyone pay the same cost per ounce, and how do you know? Okay, the correct answer is that yes, everyone does pay the same cost per ounce. If we were to find a unit rate and we took the cost per ounce, this means that we're going to divide the cost by the number of ounces to find out how much it costs for 1 ounce. So for my first one, I'm going to take $5, divide by 12.5 ounces, and I get 0.40. So that tells me that that person paid 40 cents per ounce. If I do 4 divided by 10, I also get 40 cents an ounce. 2 divided by 5 is 0.4, so it's 40 cents an ounce. 3.20 divided by 8 is 40 cents an ounce. I can look at this another way and say that if it weighs 12.5 pounds and I multiply by the price, which is 40 cents per ounce, I'm going to get a cost of $5. So 10 times 0.4 is 4, 5 times 0.4 is 2, and 8 times 0.4 is $3.20. So I'm multiplying by the same amount. We could write this as an equation. We could use a variable here, such as W to represent weight and C to represent cost. And I could write an equation that says the cost is equal to the weight times 0.4. Or I'm going to write the 0.4 first. 0.4 times the weight. And I could leave the 0 out. I could just write 0.4, or I can write 0.40, and it's the same amount. So to find the cost of any amount of yogurt, I need to multiply 40 cents per ounce times the weight of the yogurt. So for example, if we had a yogurt that weighed 6 ounces, we would take 6 times 40 cents, and we would find that a 6-ounce yogurt costs $2.40. Also true is that if we bought 0 yogurt, so we bought no yogurt at all, the cost would be nothing. The cost would be 0. We could add an extra column to the table that says if it weighs nothing, we pay nothing. And so this leads us to be able to say that the cost is proportional to the weight. And the way we know that something is proportional to something else is when we look at the table, each number in the first row, so each weight is multiplied by 40 to give us the cost. And that's true for every single place in the table. If we multiply 10 times 0.4, we get 4. We multiply 5 times 0.4, we get 2. So if there exists a number that we can multiply every first row and get the number in the second row, then we have a proportional relationship. Okay, example 2 is a cooking cheat sheet. In the back of a recipe book, a diagram provides easy conversions to use while cooking. So we can see from this chart, if we have 0 cups, we have 0 ounces. If we have half a cup, that's equal to 4 ounces, and so on. 1 cup equals 8 ounces. 1.5 cups equals 12 ounces, and so on. So the question that I would pose to you is the number of ounces proportional to the number of cups, and how do you know? So I want you to pause the video, think about this question. Is the number of ounces proportional to the number of cups, and how do you know? Okay, so the answer to that, if we look back at the previous example, we knew this was proportional because we multiplied times 0.4 each time. We multiplied by the same number. So if that were true on this example, we would also have a proportional relationship. I'm going to start with 1 and 8 because it's really easy to multiply times 1. 1 times 8 is 8. Let's see if that's true. Let's go to another easy one. Let's do 2 times 8. And that's true. 2 times 8 is 16. 0 times 8 is 0. A half times 8 is 4, because if you had 8 half cups, you would have 4 cups overall. So times 8. And 1.5 times 8 is also 12. So to get to each number in the second row, we multiply every number in the first row by 8. So that tells us that the ounces is proportional to the cups. And it looks like I'm getting disconnected. Okay, I actually lost my internet connection here, and in order to not lose the video, I'm going to try to do the rest of it without using the board, so bear with me. Okay, this exercise is one that we completed in class, so I would encourage you to take a few minutes, pause the video, do this entire activity, and then come back and we'll talk about the answer. Okay. During Jose's physical education class today, students visited activity stations. Next to each station was a chart depicting how many calories on average would be burned by completing the activity. Is the number of calories burned proportional to time? How do you know? Well, we would know if there was a number that we could multiply every number in the first row by to get the number in the second row. And looking at a really easy example, we see that 1 times 11 would be 11. Let me see if I can type this in using text. I think might be easier. So 1 times 11 gives us 11. And if we look, that is true for all of the items in the table. 2 times 11 is 22. 3 times 11 is 33. And 4 times 11 is 44. So we would say, yes, we know because there is one number 11 that we can multiply by each number in the first row to get the numbers in the second row. Okay, then down below it says if Jose jumped rope for 6.5 minutes, how many calories would he expect to burn? Well, we know that he burns 11 calories in a minute, so we need to take the number 6.5 and multiply by 11. 6.5 minutes times 11 calories. I'll move this up a little bit. Calories per minute. And we get an answer of 71.5 calories. Okay, the next example we looked at was one of a summer job. Alex spent the summer helping out at his family's business. He was hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system by the end of the summer? To determine if he will earn enough money, he decided to make a table. He entered his total money earned at the end of week 1 and his total money earned at the end of week 4. Okay, and in your notes, It then asks you to work with a partner to answer Alex's question. So the first thing we did was looked at the table, and we talked about how in week 0 he would have earned no money yet. And we kind of figured that if he earned $28 in week 1, that he probably earned $56 in week 2. But in order to be sure that this table represents a proportional relationship, we looked at this column, and we saw that 4 times 28 does equal 112. So we know that's our rule, and we can just multiply by 28. So we continued to fill in the column. If he worked for 3 hours, 3 times 28 is 84. If he worked for 5 hours, 5 times 28 is 140. If he worked for 6 hours, 6 times 28 is 168. If he worked for 7 hours, he would earn $196. And if he worked for 8 hours, he would have earned $224. Okay, now the question asks us, does he have enough money to buy the new gaming system? Well, if we look up here, we know that the gaming system costs $220. He earned $224. So he does have enough to buy it with a little bit left over even. Okay, and then part B of that question asks if his total earnings are proportional to the number of weeks he worked, and how do you know? We already talked about that a little bit when we checked to see if we could fill in the table. We decided there was a rule that when you multiply the number of weeks times 28, you get the total earnings. So since we're multiplying the first row by the same number each time to get the number in the second row, it is a proportional relationship. That's all for today. Check Canvas specifically to know what the assignment for your class was. Thank you for watching.